Alright, so we will start off with a demonstration session on IHP-WINS, and I will start off by giving you an overview of the platform, and then I want to thank my colleagues for coming out. The point is actually showing some use cases from around the water family. So we have Eleftherios, who is online from our field office in Nairobi. He's the GIS expert there. We have somebody from IHP Korea, Professor Park, and he will be speaking on real-time monitoring and the national dataset and the integration into IHP-WINS. We have Stefan Dietrich from ICWRGC, and he will speak for us on a metadata, and this is from a perspective of one of our categories 2 centers. And we have Katoria Lesaun, and he's coming from the Vrije Universiteit of Brussels, where the chair on open water science and education is at, and he will speak on some soil moisture sensors that were integrated. So we can go to our presentation. So first slide is IHP-WINS. And IHP-WINS is a water information network system, so it's the Intergovernmental Hydrological Programs Water Information Network System. And the first slide that I have is on why do we need such a water information network system. So first off, there are significant data gaps across member states, stakeholders, but also across our water family, as we have the impression that we lack harmonized and validated water-related data sets. So the available data often sits in silos across institutions and scattered across organizations, which makes it hard to use the data for decision-making and reaching the decision makers. Secondly, the decision support system can be improved. So without a centralized platform that actually transforms raw data into insightful information, policymakers and water managers struggle to visualize, analyze, and model water data. Another part is the water family is a great network, but without a common platform to share knowledge and collaborate, the knowledge that is present in our water family is hard to reach. And eventually, we think that, of course, another platform is needed to just make sure that the water family can work together. In the context of today, since we're talking about open hydrology, I want to highlight a couple of pillars under open hydrology, which is open data, open source, open publishing, open infrastructure, open education, and open participation. And actually, IHP-WINS embodies all of these. So just to say a small definition of what IHP-WINS does, it is to establish a robust and inclusive global water information system, and its purpose is to promote sustainable water management through data sharing and integration, and it facilitates evidence-based decision-making, effective governance, and it does so to ensure equitable use of water resources. Now, in the mindset of open hydrology, we're also talking about open science, and the data on IHP-WINS is open data. It is open access, and the tool, the whole platform itself is also open source and available to copy and use. So some expected results that we have there is water data integration and sharing. We want to have the water data to have a global reach. So we want to reach the whole of the water family. We want to create that decision support system that we were lacking in the water family. And we want to build capacity through the platform with courses and MOOCs. We want to use it for disaster risk reduction. And we want to support global science-based water assessments because obviously they will be based on science and data. Now, some parts of our system that I can already mention are the multilingual data catalog. Multilingual, obviously important for UNESCO, having several languages as official language. We have a geospatial viewer, we have our open learning environment, and then we have thematic viewers around topics related to IHP. And IHP-9, where they have tailored platforms for each of those topics. So the first part of the system at the heart is our centralized data repository, which is hosted on a secure UNESCO platform. It's a UNESCO Azure server. And data catalogs brings together diverse data sets, including hydrology, water quality, climate impact, and so on. A great feature that we have added recently is that when you upload a data set, that they automatically get assigned a DOI, which was requested from our water family as they urgently needed this. And again, the repository is built on an open source data management system, where today we already saw that we would like to have our data well archived, well curated, and well structured. So CCAN allows us to do so by having the metadata management features, use advanced search, and preview the data. Another thing, we say it's open access, because obviously we do not want to have everybody in the whole world uploading data to the platform, so we have user roles defined based on the roles that users have in our water family. In that data catalog, we have three parts. We have organizations, we have member states, and we have initiatives. So actually, the organizations are the fundamental contributors to IHP-WINS. They are the ones that upload and manage the data sets and define the user roles in their own organization. So this makes their data centralized in the platform, and it makes it very efficient to manage it as under one hub. The data of that organization will be available. So participating in IHP-WINS obviously contributes to the whole water family, but it's also a sort of promotion, since the organization will be visible to everyone, and they will be able to put their footprint in the platform with their data. And then organizations can obviously collaborate with each other. They do so through the initiatives, which will be next up. And these initiatives serve as a hub, since you're only the people that are part of an organization should upload data to their organization. However, multiple organizations can work together under these initiative hubs. Again, this creates visibility for the initiatives, and it's just a way of managing data in a project or in another initiative. So flagship initiatives, projects, and networks are part of those hubs. Then we also have member state specific hubs. So each data set that is related to a certain member state, because often these data sets we speak about have a georeference, are placed under those member states. And there we can just have an overview of the data that is available on the platform for each of our member states. Now again, this allows you to go into the data, into national data sets, which will allow us to, which enables us to make those science-based water assessments. So this is a big part of the system as well. A second feature beyond our data catalog is the geospatial viewer. The geospatial viewer is supposed to bridge the gap between that raw data that we upload in the data catalog and the insightful information that we have. So our viewer allows us to analyze the data on the, as you see, that's a good example over there. It allows us to compare the data, and it allows us to just extract information from the data sets that are in our data catalog on IHP-WINS. A good feature that we also have is if your data is not publicly available because you're working on a data set, or the data that you are using is not open, you can still upload it into the viewer without uploading it to the system, just to compare it with data sets that are online. We also have our thematic viewers. We have, these are viewers that are specifically under certain topics, that have been developed under certain topics. So one of them is the flood and drought monitoring system, where we have multiple early warning systems across Africa, including in Madagascar, Namibia, Malawi, and the whole list you see there. We have our eco-hydrology demonstration sites. We have our water quality monitoring portal that is being developed. We have an urban water solutions database, and then our newly citizen science toolbox, which we will demonstrate later in the session. And we have our Internet of Things platform, where we have IoT information coming from around the world into a central platform. So really, again, the key is to centralize data from around the water family into these central hubs related to the topics on the screen. Then last but not least is our open learning platform. This is really the UNESCO capacity building hub, where we organize MOOCs with water experts, for water experts, also with policymakers and other scientists. And it allows us to build the capacity within the water family, but also beyond. It is open access again. You get certificates. We have the platform again in multiple languages, and also the courses are often in the languages that are most relevant for the topic. And with that, I would like to introduce our first speaker, which is Eleftherios. So he will present a use case on GAFA. We already mentioned GAFA in earlier sessions this week. And Eleftherios, go ahead. Thank you.